You know, there's this constant, invisible chemical battle happening all around you. Seriously, it's in your kitchen, it's inside your own body, even in the dirt under your feet. So today, we're going to pull back the curtain and take a look at the basic chemistry that pretty much shapes our everyday lives.
Okay, we've all been there, right? You eat a huge meal and then, that awful feeling of indigestion. So what do? What's your go-to remedy? Do you grab some lemon juice? Or maybe something totally different, like baking soda? Well, the choice you make is a bigger deal than you might think, and the answer is really at the core of what we're talking about today.
See, that choice is basically pitting two powerful chemical forces against each other. On one side, you've got an acid. On the other, a base. You can think of them as the main characters in our story today. And figuring out how they interact, well, that's the key to solving not just our little indigestion issue, but a whole lot more. All right, so let's get to know our two contenders a little better. What actually is an acid or a base? What makes them different? It's actually a lot simpler than you might think, and it all starts with our basic senses.
First up, we've got the acids. Just think about that sharp, puckery taste of a lemon, or the tang of vinegar. That's their classic signature, that sour taste. And in a chemistry lab, their calling card is pretty simple. They turn a special paper called blue litmus paper red.
And in the other corner, you have the bases. These guys tend to taste bitter. I mean, if you've ever accidentally gotten soap in your mouth, you know exactly what I'm talking about. They also feel kind of slippery or soapy, and they do the total opposite with litmus paper. They turn red litmus paper blue.
But what's really cool is how this stuff shows up in the most random places. You know turmeric, right? That bright yellow spice in curry? Well, it's actually a natural indicator for bases. So if you get a curry stain on your shirt and you scrub it with soap, which, remember, is a base, you'll see the stain flash this reddish-brown color. That's chemistry happening right there on your clothes.
Okay, so we've met our players. Now let's talk about the rules of engagement. Acids and bases have really predictable ways of reacting with other stuff. And we're going to start with what happens when acids meet metals.
So check this out. When a strong acid comes into contact with a reactive metal, like zinc, it just goes to town. It starts dissolving the metal, and as it does, it releases these bubbles of hydrogen gas, which is super flammable, by the way, and it leaves behind a whole new substance called a salt.
And you can see that reaction happening right here. All those bubbles streaming off the zinc, that is pure hydrogen gas, literally being pulled out of the metal. It's just a powerful visual way to see the kind of energy that gets unleashed when an acid goes on the attack.
But maybe the most important reaction, especially for our story, is what happens when an acid and a base finally meet face to face. It's called a neutralization reaction, and it's basically a chemical truce. They cancel each other out. And what are you left with? Two very neutral things, a salt and just plain old water.
And hey, this brings us right back to where we started. That indigestion problem. See, indigestion is just having too much acid in your stomach. So the key here is you don't fight acid with more acid. No, you use a mild base, like baking soda, to neutralize it. That reaction is what calms the chemical storm brewing in your stomach and gives you that relief.
So acids and bases can fight it out. We get that. But how do we know who's stronger? How do we keep score in this chemical battle? Well, for that, we have a tool. It's called the pH scale.
The easiest way to think about it is like a ruler for chemistry that goes from 0 to 14. Anything below 7 is an acid, and the closer you get to 0, the stronger it is. Anything above 7 is a base, or alkaline, with 14 being the strongest. And that number smack dab in the middle, a perfect 7, that's totally neutral.
So how do we actually measure this? Scientists use these special chemicals called indicators, which, just like the name says, indicate the pH by changing color. And a universal indicator gives you this whole beautiful rainbow of colors, where each color matches a specific pH value. Generally, you see reds and oranges for strong acids, green for neutral, and then these deep blues and purples for strong bases. It's like a chemical color code.
Let's put some real-world numbers on this. I mean, what about the stuff in your own kitchen? Lemon juice, super acidic, down around a 2.2. Your morning coffee? That's acidic too, around a 5. Pure water? That's our perfect neutral 7. Then you cross over the line into bases. Baking soda is a mild 8.3, and an antacid like milk of magnesia is a pretty strong base, up around 10.5.
Okay, so it's a number on a scale. We can measure it. But so what? Why does this pH thing actually matter so much? Well, it turns out that keeping the right chemical balance is absolutely critical for, well, pretty much all life, from a single tiny cell all the way up to the entire planet.
I mean, on a huge scale, pH balance is vital for the environment. When rain gets too acidic, we're talking a pH below 5.6. We call it acid rain, and it can wreck entire ecosystems. It can make rivers totally toxic for fish. And in the ground? Oh, plants are super picky. They can only get the nutrients they need if the soil's pH is in that perfect sweet spot.
And this stuff matters right inside your own body, too. Your stomach, for instance, uses a really powerful acid to break down food. The pH in your mouth is like a constant war zone. If it drops below 5.5, your tooth enamel literally starts to dissolve. And hey, even a bee sting, that's a tiny bit of chemical warfare. The bee injects acid, which is exactly why a little paste of baking soda, a base, can help neutralize that sting.
And look, if you think a bee sting sounds bad, let's zoom out, way out, and look at a really extreme case of acidity. On the planet Venus, the entire atmosphere is made of thick clouds of one of the most powerful acids there is, sulfuric acid. It's a pretty intense reminder of just how fragile and finely balanced our own little planet is.
So, we've seen the battle. We've seen the acids and bases go at it. But what about the aftermath? What's left on the battlefield when the fight is over? Well, you're left with salts. And this family of chemicals is way more interesting and useful than you probably think. Now, when I say salt, you're probably thinking of the white stuff in the shaker on your dinner table. And you're not wrong. But in chemistry, salt is the name for any compound that's made when an acid and a base neutralize each other. So table salt is just one famous celebrity in a huge, massive family of chemicals.
And what's really wild is that regular old table salt is the starting point, the raw material for a ton of other essential chemicals. Think of it like a family tree. From that one simple ingredient, we can make things like sodium hydroxide, which goes into soap, our old friend baking soda, powerful washing soda for cleaning, and even bleaching powder, all from table salt.
But one of the most incredible salts has to be plaster of Paris. It's this special kind of salt with a really cool trick up its sleeve. When you mix the powder with water, it triggers a chemical reaction that turns it back into a hard, solid rock called gypsum. And that's exactly what doctors use to make a cast when you break a bone. It's literally using a chemical reaction to help us heal.
So we started with a pretty simple question about an upset stomach, and it's led us to this invisible chemical battle that's happening all around us, and even inside of us, all the time. We've seen how balancing acids and bases can do everything from soothe indigestion to fight off a bee sting and even mend a broken bone. So it kind of leaves you with one last thing to think about, right? If your kitchen is a chem lab and a bee sting is chemical warfare, what other invisible reactions are shaping your world right at this very moment?